Swayam Prabha. Digital India. Educated India.
Hello everybody, let's do some naming. We've been doing some naming earlier, just a little bit more complex naming than what we've done before. There's one rule that I didn't really hit on last time, and so that's the reason we're doing this one extra problem. The question we're going to answer today is, which side should you start numbering if the first substituent is the same? So this example kind of brings it home. So here is a very, very branched molecule, hydrocarbon. So where do we start when we have a big molecule like this? What do we do to find out what's a good place to start? Well, obviously, you can start top, bottom, left or right, but visually it looks like there's more stuff here and here than going up and down. I mean, if you had a very long chain going up and down, then that's where you would start. But the best thing is to go from all sides and come to a junction and see how many carbons it takes to come to that junction. So the first junction here, if you go this way, that's 1, and if you go here, it's going to be 2 carbons, and that's your third carbon. So 1, 2, 1, 2, 3. Obviously, you go this way. Now there's also and here's the next junction. Let's look at this. 1, 2, 3, 4. 1, 2, 3. So obviously, this is still longer. And you keep going like that, checking the junctions. Go over here, obviously 2, so we're not going that way. And we go here, that's 3 up here. But if you go this way, 1, 2, 3, 4. And so that's really not a long chain. So here's another junction here coming to the other end. Well, should we number it 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There are 3 ways to get to that junction. Which one should we take? Okay, so the rule says longest chain with maximum branching. So if we go this way, there's only 1 branch. If we go this way, there's only 1 branch. If we go this way, there are 2 branches. You see? So that rule kind of sums up all the main rules on the naming. So when we go here and here and here, that's going to be our longest chain. So then, now that's settled. The next thing is, we number the parent chain to give the lowest number to the first substituent. So over here, 1, 2, 1, 2. Well, that rule really doesn't help because they're going to give you the same number if I number it this way or this way. 1, 2, 1, 2. Well, then number the chain to assign the lowest number to substituents overall if the first substituent has the same number. So then we got to see which would be the best way to number to give the lowest possible numbers to all. That's the key, lowest possible number. So I'm going to go numbering from this end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it doesn't matter whether I go right or left because it's just 1 carbon there. This way, 3, 4, 5, 6, 7, 8, 9, 10. Obviously, it has to have the same number because you've chosen the longest chain. Now, it's kind of hard to tell. So let's write down where the branches are if I go the blue direction from like California to Maine, or if I go the other pink direction from Maine to California. So let's say we have 2, there's something at 3, 4, 4, 2 things on 4, 5, 6, 7, pretty much every carbon has got something, 9. If you go on the pink route, 2, 3, 4, 5, 6, 7, 7, 8, 9. So basically, you got most of the numbers the same, and over here you got a lower number, here's a lower number, and same here. So overall, these are the lower numbers for the possible numbering systems. So therefore, we are going to go this way, the blue way, and not the pink. This is not correct, and we're going to go this way. So that's how you do it. If you're not really sure, you can even sum it up. So it should be the lowest total. Okay, so going over here, now let's see what's coming off of all of this. So on 2, 3, 4, and 9, there are 4 methyl groups. So let's list them. 2, 3, 4, and 9. You have tetramethyl. Then we have 4 has got a third butyl, 5's got an isopropyl. 4 T-butyl and 5 isopropyl. Now you got to be mindful when you have iso, because that's going to be alphabetized with the I. And 6 is going to be just N-propyl, so that's going to be with a P. And then this is isobutyl. There's 4 carbons branched at the end, isobutyl. And so there are 2 isos, so then you have to go by the B versus the P. 8 ethyl, and we already said 9 methyl. So we're going to alphabetize them. Obviously B before E, and then IB before IP, and then M before P. So that's going to be 5, and then this will be your 6th substituent that you're going to mention. Okay, so let's start by mentioning the kids hanging onto this long chain, starting with 4-T-butyl, then 8-ethyl, again no spaces, dashes between numbers and letters, and 7-isobutyl, and then 5-isopropyl, and 2, 3, 4, 9 tetramethyl. I'm going to write it here. So 2 will come right here. 2, 3, 4, 9 tetramethyl. And then 6 N-propyl. And then the parent is obviously 10 carbons long, no space, decane. So that's one way to name it, and we can also name it with the proper method, the complex method here, where we would be calling the T-butyl, then 1,2,1,1-dimethyl ethyl. So this is the same as 1,1-dimethyl ethyl. And then we would use the first letter for alphabetizing that. Isopropyl would be 1-methyl ethyl, methyl ethyl, and N-propyl is going to be the same. The ones that are not branched are going to be the same as the branched ones that are going to be named differently. 2-methyl propyl is isobutyl, 2-methyl propyl. Now we alphabetize the whole thing according to the first letter. So we alphabetize the whole thing now again. So here we are going to do the alphabetizing by the first letter with the pink. So this is still going to be M-methyl, tetramethyl. This is going to be propyl, and this is going to be ethyl. Here I'm just going to write it down just to make it easier. Propyl, and here we're going to be methyl. So the order for this order of numbering for this one, if you do the complex one, is going to be, first it's going to be D, dimethyl ethyl, and then it's going to be ethyl, and then it's going to be your M's, and then here's a M, there's nothing following that. Again, tetra is not going to be considered in the complex or the simple or the N. If it's within a parenthesis, then you will consider tri, tetra. This is not within a parenthesis, so that's an important thing to remember. Then you 4 and then methyl propyl after methyl ethyl and then propyl at the very end. So when we will start, this is your complex naming. All right, let's do the complex naming. We got it alphabetized in order here, so let's just bring them in. Just remember that the positions don't change because they're fixed on the chain. So it'll be 4,1,1 dimethyl ethyl. Eight ethyl. And then this is going to be 2,3,4,9 tetramethyl. And then there will be a dash after that. It says one name, no space. I just don't have space, so I had to bring it over here. 5,1-methyl ethyl. And 6N-propyl. And then your parent's going to be the exact same one, and I would write it right here without any space. Since I don't have any room there, I'm writing it at the bottom. So it looks like a handful and a mouthful to say, but we have to just make sure everything's alphabetized, follow the rules for the side chain naming, and then put it all together. I'm sure with practice this would be really simple. Actually, this method is really simple because you don't have to memorize anything. You can just go by the positions of the side chains within the side chain and then number the side chain, and then you can keep going. I think if you're doing your MCATs and so on, you may want to learn this method. Okay, we'll come back with more naming with some spiral compounds. Let's see what those are. Talk to you soon.